Welcome everyone to another Domo live stream, a part of our AI Insights series. It's actually part 4. We've done a few of these over the course of the last several months over universal models, forecasting, PII, sentiment analysis, and beyond, which is the official title of this live stream. Thank you guys for being here. We really appreciate everybody joining live and interacting in the chats or comment section, wherever you may be joining us on Facebook, LinkedIn, and YouTube. And as soon as I pushed the live button, I thought we were going live on Twitter, but apparently Elon wants his money. So we are not live on Twitter because we are not a premium user on Twitter, even though we have, hundreds of thousands of people that are tens of thousands, hundreds of thousands, I don't know what the official number is, joining us on Twitter. So thank you guys for being here. Again, interact with us on the chat, provide some comments. As always, I'm joined by better faces than I. Face for radio is what I've always said. But the AI Labs team to basically jump right in and kind of provide some benefits to you on what a low-code AI solution looks like. As you know, they've been kind of our featured speaker during these events, and we're always happy to welcome them into the live stream. Today's AI Labs team will specifically be exploring how to leverage universal models for those aforementioned activities that you may be doing on a daily basis. So really excited to turn it over to them. We were discussing our summers earlier, just really kind of chatting about the nature of the community. Obviously, these AI live streams have been a big part of kind of sparking conversation on our community forums, which community-forums.domo.com. We'd love to see you there and continue the conversation, but also just interacting with some of our blogs and some of the other pieces of content that we're able to pull out of these sessions. And we couldn't do it without you guys joining us and engaging and interacting and asking questions as an audience. So again, thank you for being here. Shelby McNeil, our data scientist from the AI Labs team here at Domo. Shelby and her team, Vishaka, Brian, and Davis, should be all ready to give you the goodness, and then I can get out of the way. Shelby, thank you again for bringing your team and being a part of these.
Thank you, Eddie. As Eddie mentioned, feel free to comment throughout the webinar. We'll have people in the chat answering those, or we may answer them live. So we'd love to hear your thoughts, feedback, questions during this webinar. So as you're all aware, this webinar is about universal models. And in a nutshell, what is a universal model? It's a pre-built model by us at Domo that will be available to all users. It's meant to be a low-code model that's easy to set up, easy to use, easy to track. And right now we're working on 3 specific universal models that we'll walk through today: forecasting, personal data protection, and sentiment analysis. So the majority of this webinar will be demos and talking about these 3 universal models. But before we dive into that, I want to give just a very brief overview of what is a model, what type of modeling have you been able to do in Domo prior to this, and how are universal models different? And then I'll wrap up with a brief note on when these will be available. So to start with, when I say model, what do I mean? What I mean is a model is just an equation. An equation is something where you have inputs that you add or subtract or apply math to, and you get some kind of output. So we're all aware of equations. We've learned these as very small children. Here, this very easy, simple equation is A plus B equals C. As you can see here, you've got inputs and you get some kind of output. And you can put lots of different information or data into this equation. So in this case, you could count up the number of apples you have or the number of dollars you have, etc. So when we do models, like when we say AI models or machine learning models, data science models, we're really just talking about more fancy equations. These aren't magic, is what I want to get across. So as an example, we're going to be talking about a forecasting model coming up with Vishaka. So I'll let her dive into the specifics of that. But as you can see here, this is literally the math that is powering a specific kind of forecasting model. As you can see, there's a bunch of inputs, again, in purple that you're adding and multiplying together, and you're getting some kind of output in orange. So in this case, I might want to forecast my revenue for next week. I just supply the model with my previous revenue. apply the math there, and I get an output of, you're going to get $15,000 in revenue next week. So, in summary, a model is an equation, it's not magic. So, when it comes to modeling and what you've been able to do with models previously in Domo, Domo has been really great at custom modeling. So, to go to the next slide, what is a custom model? Well, it's just an equation that's been specifically built based on your data and your use case. So think of it as being specifically tailored to your data and your questions. Because this is a custom model, you have to build it yourself and train it. And the tools that we offer in Domo to do that are things like Jupyter Workspaces, AutoML, and Magic ETL scripting tiles. In this picture on the slide, this is a screenshot of Jupyter Workspaces. You'll notice that this has some code regarding sentiment analysis. So this is showing if you want to build a custom sentiment analysis model, you have to know how to code. In addition to that, you have to usually have some kind of advanced statistical knowledge to be able to figure out how to set up this code, how to train and test it. Now, what should probably be obvious is that all of this coding, this development, it takes time to maintain and productionize. But one of the benefits is that you get really, really good performance and accuracy. So while these are great tools for some of our customers who want to do custom modeling, we here at Domo realize that not all of our customers have the time, the skills, or want to spend the money to build a custom model. And so that's why we've started to develop universal models, which is what we're here to talk about today. And really, universal models are meant to be pretty much the exact opposite of a custom model. So universal models are supposed to be one size fits many, and anybody can use it as long as they have a data input that meets the model requirements. Another way to say this is it's just a generic model, a generic equation that should generally work well for, as an example, forecasting if you want to forecast. Like I said, these are going to be pre-built by us here at Domo and will be available to all Domo users using some of the tools that you all should be familiar with. Domo apps, cards, Magic ETL. The specific tool will obviously depend on the specific model. These are meant to be business user friendly, no coding required, minimal setup. And like I said, because it's a general model, you're supposed to get pretty good performance, especially as a starting point if you've never done any kind of modeling before. So in conclusion, universal models are meant to be for a broader audience and much less work to put together and maintain. So I want to know, before we dive into the demos, when the universal models will be available. And I'm just going to be upfront that none of them are currently available today. They're all still in development, but we wanted to show you all where we're at with these, the progress that we've been making, and just get you excited and ready to use these when they are available. So most excitingly, forecasting will be available in September coming up. And then our models regarding personally identifiable information and sentiment analysis will be available in coming months. So stay tuned. And with that broad overview, we can now dive into some of the actual demos. So I'll turn it over to Vishaka to talk about our forecasting universal model.
Thank you, Shelby. All right. So one of the first ones that we identified as a universal model to start developing and putting it in like the Domo toolbox was the forecasting model. And I just want to revisit some of the basics of a forecasting model real quick, because that will help us tie back into why we chose forecasting as a universal model, what are some of the benefits of using it, and how you'll be able to use it just out of the box without having to build a custom model by training your data and having to write any code. So let's dive into some basics real quick. If you have attended some of our previous webinars, you might have come across this, but as a highlight, what is forecasting? Forecasting involves predicting future outcomes based on historical data. So here we have an example of orders, customers' orders by month. We see order month or date on the x-axis and the number of orders on the y-axis, and we can quickly see some patterns here. We can see there are peaks and there are valleys, and we can assume that based on this data, you can also see that the model was able to forecast future orders, and it kind of looks like a rhythmic pattern, right? So you feel like you can trust it. What makes it so? So why use data? Why use data on past to predict the future? Because future is likely to look like the past. I want to go to the previous slide real quick, because here we saw there are peaks in February, and I see valleys or like a dip in orders in summertime. And so if we were to forecast, I would expect, again, another peak in around February or March, and we see that kind of trend going up. So future is most likely to look like the past. This is another example of retail employment trends, and we see this historical data. And what most of the algorithms do are they look for three main components in historical data. The first component being a trend. Does the historical data show a natural trend? It can be increasing trend or a decreasing trend. In this case, we see an increasing trend. The second component we see is, you see, like with previous data here, you see some more, but you see some cycles, ups and downs. And so we call that seasonality. So we see repeating cycles, which indicate seasonality. It can vary depending on the date grain you're using. It can be hourly, weekly. The cycles can repeat in different weeks or days or months, depending on what data is. That's the second component that most of the algorithms look. And the third one being error or noise. Not everything can be explained by these two components. Whatever is left is the noise. With that being the case, how can we apply these three components to predict the future? Apply the trend, apply the seasonality we saw, and apply the error, which will provide us with a buffer, and you have a forecast. With that basics of models, we want to dive into what constitutes a forecast, right? Like we mentioned, there is error involved. So a forecast will most likely never include just one value. It will include like a range and a confidence interval, and that's what you see here. So there are prediction intervals, which is indicated by the gray zone, and there are point estimates indicated by the orange line here. Also, the closer you are to your current data, the more accurate you are, the further out you forecast. Algorithms can forecast up to twice or thrice the amount of your historical data, but the further out you go, the lesser accurate it becomes. So with that, how do we apply this knowledge to what universal forecast will be good at? Of course, we want one size fits all, and we want a forecast to be excellent at any data. But there are some things to note. Anything that can be observed sequentially over time or has a strong pattern is a good candidate for a universal forecasting model. Most common examples are revenue, sales, course enrollments, and resort attendance, like a park or a ski resort attendance. These metrics or these KPIs are expected to follow a certain pattern. There is seasonality involved. There is natural trend involved. So these are great candidates to forecast. Technically, you can plug in any historical data to a forecast. It is not going to complain. It may, there is a high possibility that it will not error out, but you will also most likely get a straight line for some kind of data, for some kind of historical data, and those being random events. Now here, if you see this chart, you see like cycles. It can seem like there is seasonality involved, but if you look closely, the seasonality doesn't repeat itself. It's not predictable. So even though it looks like there are definite, highs and low points, this will not result in a great forecast because I don't see a trend. I don't see a seasonality. Everything that I see is pretty random. So here are some examples of what will most likely not be a good candidate for a universal forecasting model. So some pointers on what we need to do in order to forecast. Um, Again, the data needs to be sequential. Ideally, we don't want any missing periods in this example. And these are the two metrics we'll need for the forecasting or the universal forecasting model is a date column and a value column. It can be it can be currency, it can be units or the number of units or anything, but a date and a KPI. Ideally, we don't want any missing periods. How many are allowed, how many are not allowed is a hard question to answer. It depends. A couple of missing in this example, monthly example, couple of missing, maybe one or two missing columns will the model will be fine. It may not error out. But if you have more missing periods, if you have sequential missing periods, then it will most likely misinterpret it for, if I miss June and July, it will think this month is coming after May, and it will try to find seasonality in what is available. So ideally, you don't want any missing period. You want one column of date. I kind of going out of order there, but one value column, one date column, sequential values, and can't have lots of missing data. Another example here is, here is the example. So let's say I want to forecast on this one, right? So I have what looks like a little more than a year's worth of data, and it's a monthly data set. And I want to predict, let's say, the next 12 months. The seasonality is 12 months. This model will most likely not work because I am only providing the model less than 2 years of data, and I'm saying the seasonality is 12 months. So it will need at least two full periods to figure out that seasonality. And if it's not able to do that, it will say, incomplete data or not enough data. So I know it's not always possible to have plentiful data, but whatever data you can provide for the seasonality that you're claiming that the data has will be ideal. So most of you might be wondering where and how could this for a universal forecast be accessible? It will be accessible in cards via App Studio. You will be asked when creating this card, you'll be asked some questions like what's the date column, what's the value column, what's the granularity, how many future periods do you want to forecast and all that. But you can plug this model in directly with the card and you can create a forecast. So no need to create an ETL, save it to a data set, and then do a visualization. However, most of us want our forecast to be materialized in a data set. So you can also use the forecast in a magic ETL data flow and have it update or saved it to a data set for more wider use than just a card. You can also use it in Jupyter for some advanced analysis. So you can call that model in Jupyter and do some more analysis or more processing on it, and then make it available any way you want it in a data set or card. And last but not least, workflows. So you can you can use the model within a workflow to do things like, if you see a dip in sales, then alert someone. If you see, if it sees an unexpected rise in orders or something, then alert someone else, things like that. All exciting stuff. All right. So what options do we have for universal forecasting models? So we are providing, Domo is providing a default model So it's you'll have it available. When it becomes available, you'll be able to choose between a REMA or an ETS model type, but you also have the option of bringing your own model. So if you have a forecasting model that you're hosting elsewhere, you can connect it to Domo. And if you want to use it in Domo, you can, by connecting it in Domo, you can use it in like all these other options that I mentioned here within Domo. So lots of possibilities there, and we are so excited, given how easy and how less data in terms of like the width of the data. You don't need a lot of columns, you just need a lot of rows. Given all that, we're excited to see what Universal Forecast does for you. Stay tuned. That was me. And then I will move to, or Davis is going to move to the personal data protection. Davis, can you remind me, do you want me to keep sharing, or do you want to share?
I can try sharing. We'll see if that works for me. It's giving me issues a second ago. Give me 1 second.
I see it. Yep.
Okay. Awesome. Sorry about that. Looks like I might be only sharing the top section of my screen. Give me 1 more second. I'll see if I can try that again.
And while Davis is setting that up, I just want a reminder, those that are watching that have questions or comments or feedback from our AI Labs team, please throw those directly into LinkedIn, Facebook, or YouTube, wherever you may be watching. And we'll have a team of folks that are kind of in the background answering those, as well as trying to take those on air. Davis, it looks great on my end. Full screen this time. So let's do it.
I think I fixed it. Sorry about that. All right. Yeah. So our next universal model we wanted to talk through helps customers handle personal identifiable information in their Domo instances. Personal identifiable information, or PII, refers to any data that can be used to identify a specific individual. Information such as names, email addresses, social security numbers, credit card numbers, street addresses, and many more. Managing PII is crucial for several reasons. First and foremost, protecting PII ensures compliance with legal and regulatory requirements. Various laws such as GDPR in Europe and CCPA in California mandate strict guidelines for the collection, storage, and processing of personal data. Failure to comply can result in fines and damage to a company's reputation. While there are numerous off-the-shelf services available for detecting PII, they often come with their own set of challenges. One of the primary concerns is cost. Many detection services can be expensive, especially when you have a large number of large data sets. Another issue is the lack of customization. PII detection solutions may not always align perfectly with your specific needs and nuances of your data. Customization can require specialized knowledge and additional resources, which can escalate costs and timelines. Lastly, many existing PII detection services out there, they struggle with structured data. They do a pretty good job at identifying PII within unstructured data like documents and emails and kind of raw text, but they don't perform as well with tabular data like a data set you might be used to working with in Domo. Structured data typically follows a defined format and can include various types of PII spread across different columns of your data set. So detection algorithms designed primarily for unstructured data might overlook those PII risks and could cause some problems. Domo's universal PII model will aim to solve these problems by providing an easy-to-use, powerful, and flexible PII detection system, all within the Domo instance. Similar to other universal models, PII detection can be run without any significant data prep or model training, bypassing the traditional and costly development cycle required for a custom solution. So let's walk through a simple example here. We have a data set with 4 columns, name, department, email, street address. It's easy enough for anyone to look at this to determine that name and email and street address are personal information, while the department field isn't really that identifiable. When we pass a data set like this to the universal model, we will get an output similar to this. So the result of the model is itself a Domo data set. And almost as if we had pivoted that input data, you'll notice how each row in the result table represents a column from the input table. This is just a simple example, so we only have one data set here, but you could imagine multiple input data sets, and we'd have some more variety in this output set here. It gives us our PII type and also the confidence score, just to add a little additional insights while reporting. And because these PII results are returned as a data set, they can easily be used for inputs and ETLs, workflows, powering cards, and alerts. So it's really flexible what we can do with the results there. And speaking of using those PII results, the little example I have here, this bar chart on the left, is a good example of the importance of not only detecting PII, but also classifying what type of PII is present in the data. Not all PII is created equal. Applying specific security rules for each PII type can protect sensitive data without hindering the usability of your data. So in this example, knowing that there are 3 columns out there with social security numbers might take a higher priority than those email addresses that there is 100 of them, but it might not be as sensitive as a social security number. And when you're ready to analyze your data sets for PII, you have several options, ranging from basically scanning every data set in your instance for PII, or maybe just analyzing the data sets that you own, or applying any sort of filter criteria to data sets and running the PII model on those subset of data sets. PII results can also be generated and viewed directly from this data profiler, which gives you a quick glance at potential PII concerns at the dataset level. Users can take action on these columns, or at the least just be aware of the potential risks in the data that they're currently working with. And knowing where and what type of PII exists in the dataset will also help inform the management of PDP policies. And as I wrap up, it's just important to remember that all universal models are dependent on clean input data. The common phrase garbage in, garbage out not only applies to training models, but also model inference, which in the case of PII detection, clean data primarily refers to the consistent and organized data schema strategy. So having reasonable names for your columns makes a huge difference as the universal model uses that information to determine what PII might be inside the columns, as well as managing your null values. This goes for all models, but PII obviously can't, the PII model can't detect what's inside the column if there's nothing inside. So managing those strategically can greatly increase your accuracy there. And that's it for the PII.
Not hearing you, Eddie. Are you on mute?
Yeah, thank you.
Hey, there we go. Yep, no worries.
Right, the host doesn't have his microphone. I just told you, I was telling everybody before this, I have a new microphone, and if I get dangerously close to the front, it's like a touch sensor that taps. Yeah, not fun at all. So I was just saying that LinkedIn has changed the way we're allowed to interact with you. So I'm trying to manually go to LinkedIn and answer some questions that came in. Had my screens all messed up, so I was a little late on that transition. Apologies. Brian, back to you, my friend.
No problem. Yeah, let's dive in. Let me get this shared correctly. And we are good to go there.
We are ready. Thank you.
Thank you. Yeah, so this third universal model type that we're going to talk about is sentiment analysis. And we're in the early stages of building this universal model. So we're going to talk a lot about all of the considerations we're taking into account as we build that for you all. But let's dive in. Like Eddie was saying, we were discussing summers earlier, and there have been a lot of great community events with AI webinars. And one thing that commonly happens in the summer here in the US is people going on vacation and taking road trips. And if you've done a road trip, then you've probably had the absolute pleasure of stopping at a gas station and using their restroom. And often, not often, but I've seen a couple of these outside of restrooms and gas stations where you're asked to relate your experience through pushing a smiley face, a meh face, or a frowny face, depending on how you felt about your restroom experience. I'd say that the gas stations that have these generally are paying more attention to their cleanliness, and so it's going to lean towards that smiley face. But this is a really good example of sentiment analysis just at face value. We're trying to understand how people feel about their experiences with either an experience like this restroom, with a business, with our product, something like that. And this is a really nice cookie cutter way for that to be input for us. It's really structured. We've got a smiley face, frowny face, or a meh. So with sentiment analysis as it relates to modeling, it generally can get a lot more complicated than that. And with AI and with data science, what we generally are working with is unstructured text data. So just in sharing sentiment analysis with you today, I really want to drive home that there is just a broad amount of ways that sentiment analysis can be approached, and a lot of different challenges that we can face and levels of depth that we can go to extract a lot more value out of sentiment analysis. So we'll be giving an example of a generative AI prompt later on that can help with some sentiment analysis. So like I just said, as it relates to modeling, sentiment analysis is extracting structured opinions or emotions of an author from unstructured text. So that's the challenge that we kind of face with that. With a lot of data science and modeling, we work with structured data where we're able to see a column and work out how that relates with other columns. With sentiment analysis, we're working with blobs of text, and we're trying to understand how they relate to how people feel about our company. So that is generally the reason that we do sentiment analysis. We want to understand our customer base and their needs. And this happens in a lot of forums. This is not an exhaustive list, but we can see that through going out into the wild and trying to gather social media posts, trying to determine whether people, when they mention our company or product, if they felt good about it or not. We analyze reviews. There are a lot of really good forums where we can pull reviews from: Yelp, Google, Amazon for products, and get an understanding of how people feel about things. Employee satisfaction surveys, that's a way that we could do that internally and look at sentiment analysis and say, hey, how do you feel about our company? What are things that we could improve? Things like that are kind of open-ended questions that we might have unstructured responses to that we could apply sentiment analysis to. And then finally, again, not an exhaustive list, but another thing that we could see this used in is taking a look at customer service call transcripts or maybe sales calls and trying to categorize how people felt in that call, what the call was about, things like that. So you can see here, this next section is how is sentiment analysis done? The reason that modeling comes into play here is because if we're lucky and if we're fortunate enough to have a lot of feedback from our customers, we generally will have way too many responses and reviews or social media posts to really go hack at it manually. If we have maybe 20 reviews of our business, we could just send an analyst there and have them over an hour or even less time categorize how people felt in those reviews. But given that we're generally working with large amounts of reviews and large amounts of text data, we do need to hack at this with a modeling solution generally. Like I said, we're in the early stages of building the universal model for sentiment analysis, but it is going to be something that's going to be really valuable. I think that Shelby earlier mentioned that universal models are really great starting points. And so we're going to look at a starting point for sentiment analysis, and we're going to look at how you can go a little bit deeper on sentiment analysis. And so as we're kind of building that universal model, we're thinking about the different levels of depth of sentiment analysis and how we can try to fit those to everybody and their needs with analyzing the sentiment of text. So let's dive in on that initial just basic sentiment. like I said, really basic version of this is that smiley face that you push at a gas station or maybe even at a cashier or checkout register. That's something that's going to come out structured. It's going to be positive, neutral, or negative in each observation of that of that clicker being pushed. With text data and reviews, we're going to hack at that with a sentiment analysis model. And the way that that works is that a sentiment model will look at a response and it will assign a polarity score to the unstructured text. So it's going to read the text and it's going to give you a number between -1 and 1. And when you get that polarity score, you set your own thresholds to define what the labels are going to be of that polarity score. Generally, the lower your polarity score is, the more negative the text in the review is. The closer to 1, the more positive it is. So generally, you'll set some thresholds. I think in this case, we put it at like -0.1 and +0.1. Within that range, it's considered neutral. Below the -0.1, we considered a review as negative, and above 0.1 positive, we considered it a positive review. And so just at that basic sentiment level, we're able to understand over thousands of reviews how people generally feel, and we're able to aggregate that information. So you can see here that we're over 50% positive. We have a pretty good chunk of negative though. If we look at the individual reviews, we can see how that was classified by the sentiment model. This one says the manager was really nice and accommodating, and it got a 5-star rating. So that positive seems to have worked out. There's a negative down here that says the worst, most rude customer service of any corporation. So you can see that's clearly negative, and our model classified that as negative. If you're seeing that your model is misclassifying a lot of these reviews, you can adjust the labels, those thresholds that we were talking about for the labels. And so that's a way that you'll probably go through this. You would have the output of this basic sentiment where it says thumbs up, sideways, or down, and then you would take a random sample of maybe 20 to 30 of these reviews, manually test the accuracy of that sentiment model, and then adjust your thresholds accordingly. So this is really nice, and we've got it at face value here now. We're able to see on an aggregate level, how did people feel about this is a 1,000 reviews from a clothing store. So how did people feel about that clothing store? And we've already got a star rating, which gives us that information pretty well. This went a little bit deeper, but we can go even deeper to really understand what's driving people's experiences, rather than just knowing, is it a thumbs up or thumbs down? And one of the best ways to do that is with topic modeling. And so we would do that by taking a look at the sentiment by different topics. So depending on your business, you probably know a couple of the most important drivers of a person's experience, either with your product, with your store, with your company in general. And in this case, what we've used is we pulled a Hugging Face model from Facebook into Domo, and we were able to apply that classification model to these reviews to be able to classify the reviews as most relating to one of these topics of interest for our business, for this clothing store. And so the really cool thing about this classification model is you're able to provide the topics that you think are most important. So for this store, we thought that prices, selection, and staff were most important. And so we provided that to the model, and this model identified whether the review was about prices, about selection, or about staff. And so by doing this, we're able to understand not only did somebody feel good or bad, we're able to understand what made them feel good, what made them feel bad. And we're able to take actionable insight from something that goes this one level deeper of looking at topics. So if you look at this, we see that prices are pretty closely matching what we saw on the overall scale. They're a little bit more positive, selection is way more positive, and then staff seems to be where we're dealing with the most issues as far as people having negative experiences with our clothing store. So we've filtered our reviews now to try and get a more granular sense of what's going on and what's causing that. And you can see that review we already saw. The manager was really nice, so that was a positive. But here we go. I'm your loyal customer. I love your clothes, but today customer service was the worst one. Interesting wording, but negative, clearly negative. And so this, again, just taking it one level deeper, helped us to understand why people were having the experiences they were having. So this is great. One other way that we're able to take that customization a little bit further is by utilizing LLMs. So in this case, I engineered a prompt for the in the Domo AI playground using text generation. The really cool thing here is that sentiment analysis is very much unstructured text based. And because LLMs are trained on unstructured text and they work a lot with unstructured text, this is a really good source for us to go to kind of analyze a lot of the reviews and unstructured text that we have. And again, generally the idea of sentiment analysis is taking that unstructured text and aggregating it in a way that allows us to really have it more structured and do some analysis and get some insight into our unstructured text. So with an LLM, if you've messed with ChatGPT, if you've messed with LLMs, you understand that you do have to engineer your prompt very specifically in ways that will help it to respond to you in an accurate way. So here are a couple of tricks that I've used and we've used here to improve the accuracy of this sentiment analysis. And again, one of the goals that I really needed from this LLM was to structure my sentiment analysis and this unstructured text. So the way that some of the tricks that I've used to do that is using XML tags to parse this prompt. You can see here I've got a couple of tags. This is the review. This is a list of tasks that I expect the LLM to do. And then this is the output format I expect at the end. And so by putting the prompt within these tags, the LLM is better able to interpret what's going on. I'm able to reference these. I say, analyze the following review. It knows to turn here. I tell it to go through the task of a 3-step process. It turns to that task. And that is another tip here, is to provide a step-by-step process that it can follow. And then finally, specifying that output format is really what's going to make me capable of using this output in some sentiment analysis. So again, right here, we're just looking at a review of a new shoe for our clothing company. They said, I like the color of the shoe a lot. It really stands out. The shoe hurts my foot if I walk in it for a long time. So we then look at the task, which is to identify up to but no more than 3 important topics, determine the sentiment of each topic, and then follow the specified output format. And the output that I received was color, positive, comfort, negative. So that's another way that you can get even more granular and get even more customized with a sentiment analysis model, is utilizing an LLM. And again, using these prompt engineering tips is going to help you get the output that you expect and be a little bit more accurate with the output there. So in summary, we're really excited about sentiment analysis and universal models in general. The sentiment analysis is still in its early stages, but we've got a lot of exciting things coming in the way of sentiment analysis here. Got you on mute again, Eddie. Sorry.
No, I'm gonna send this new mic straight to the moon, I think. I promise this isn't the first time we've ever done a live stream. I have no idea what's going on. I'll bring back Shelby, Vishaka, Davis, and Brian, who just finished up. We got lots of tech stuff happening today, which is always fun. They change the platforms all of the time. That's why it's always somebody's full-time job to be a social media manager, Don't ever let them tell you different. It literally changes every hour on how we can communicate and engage with you. But hopefully we've answered a lot of your questions on the chat, whether it be through LinkedIn or Facebook or YouTube. Shelby, any parting words about this part 4 universal models, our AI Insight series, before we let the good folks go? Davis, Vishaka, Brian, excellent job. Fantastic.
No,
Thank you.
Thank you. Not too many parting words. Just wanted to mention that these recordings of the webinar should be available at the same LinkedIn link that you joined at, or on YouTube, or however else you're joining. You should be able to watch the recording. We also have a Domo data science resources guide available on developer.domo.com, where we'll post the recording and the slide deck as well. So thank you all for joining. And again, we look forward to sharing these universal models with you. Forecasting should be available in September, and then personal, the PII model and sentiment analysis in the coming months after that. So thanks for joining today.
That's awesome. Thank you guys so
I did
much.
have
Oh, go ahead.
Oh, before we part, I did have I did want to address Patrick's question again. I know he had to drop off, but that is a question that we anticipate coming a lot. His question was, and I'm going through the comments again here to. So what is different between this universal model and the model that that's already available in, let's say, a tile or a card? Excellent question. So the key difference here that I want to say is consistency, right? When we started off building these AI and ML capabilities in the product, they were built in different places. What we are trying to bring in is the consistency. So when the AI services layer was released, what that allowed us to do is attach, give the flexibility to attach any model that a user wanted, whether it's hosted in an external product, bring it in, attach it to the forecasting task, or build your own model and make it the official model that you use for forecasting. Or if you don't want to code, you want to use something low code, then use something that's already available in Domo or with that task. So by doing that, by attaching it to that services layer, or that the forecasting tile or the forecasting task, allows you the consistency to use the same model in the Magic ETL tile, in the card, use it in Jupyter, and use it in workflows. So if you use the same data and the same inputs, you'll always get the same results, and you'll not be using different models in all these different places. So consistency and flexibility is what you're getting from this. That's it.
Awesome. Thank you. Thank you. And as always, our good friend Jason, who's watching this, was great. Thanks, Shelby, Vishaka, Brian, Davis, one of our good friends in the community. So we appreciate everybody joining us. As always, as Shelby said, same bad time, same bad channel. Wherever you pick up these links, you'll be able to watch the recording immediately upon the conclusion of the event. I feel like it is something we put in almost every session now, but the questions keep coming, which is great. They will always be at the same place you found it. It literally will be re-uploaded as soon as I hit end live stream. Awesome. Thanks again, everybody, for joining. Our audience members, our community members, keep engaging with us. We'll have another AI Insights series session in August, so be on the lookout for those links as well. Thanks again, everybody. We'll catch you on the next one.